Okay, good morning, everyone. Of course, I will talk about BRAMS, but I've been a little bit lazy, so my apologies for those who were at the radio workshop 2 days ago. This will be mostly the same thing. So I'm going to give you a little information about the status of our network and our plans for the near future. So this is the, well, first of all, I should remind that Stijn already did it during his presentation. So BRAMS is a forward scatter system. So the transmitter and the many stations we have are not co-located. And currently we have, oops, sorry, this one. So we have the transmitter here located in the south of Belgium, not so far from here, actually, we are here. And we have currently 46 active receiving stations, and we keep spreading with time. And the red circle is our interferometer located in Human. So this is our BRAMS transmitter. We transmit at 49.97 megahertz, continuous wave with no modulation, a power of 130 watt and circularly polarized. I don't go to the technical details. One thing that has changed, let's say, in the last 2 years, that now we are monitoring very closely and very often the BRAMS transmitter, because we had problems with our power amplifier. I think that was last year, that we bought from the Australian company, Tomco. And then we felt that it was absolutely needed to have a regular monitoring. So we are doing that with two different ways. I just show you here that we are using a directional coupler to measure the transmitted and reflected power. And these are the kind of results that we obtain every minute, so that we can use this, for example, in the future for power measurements. Everything is so here you see the power amplifier. This is the signal generator. This is the GPS discipline oscillator, and everything is controlled by this Raspberry Pi that we can control remotely. But it's not yet in a control environment temperature. You actually see this guy there. But this will be the case in the next month or so. So in the receiving stations, we are kind of in an hybrid system at the moment. So 14 our stations are still using, let's say, the old material that we were using from the beginning. So analog ICOM receiver and combined and controlled by a PC, which means also Windows and all the programs that are related. But 32 of our stations are now using Raspberry Pi. Our own code to control everything, and RSP2 digital receivers. And of course, there's the radio interferometer in Human. This was the material that we were using for the old stations. This is the ICOM R75, but I don't go into all the technical details. These are the new ones. So we have the RSP2 receivers here, the Raspberry Pi. And was the case also for the first station. So all our stations are synchronized using PPS from the GPS clocks here. And that's very important, because you will see in the next talk by Joachim that the only information we get for reconstructing trajectory and speed are the time delays between the appearances of the echoes at the different stations. And therefore, we need to have a very good time resolution. We are sampling the signal at 6 hertz. So basically we have, in theory, precision of 0.16 millisecond due to the GPS clock. Of course, and Joachim will show you, we have additional error measurements, of course. And this is the material that we are using for BRAMS, and of course, it's in the back of my car. I forgot to bring it. But it's now an A-size system. It's very compact. It's very easy to set up. It's kind of plug and play. You plug the two GPS. So the second one is used actually for frequency stability. Here you see the Raspberry 2 receiver, the RSP2 receiver, the Raspberry Pi. This is a BRAMS calibrator, and this is a GPS disciplined oscillator. So now everything is very compact and easy to use. I made a little demo 2 days ago for the people attending the radio workshop. Now, I quickly show the radio interferometer in man using the classical Jones system that you've seen also in the presentation of Gunther. These are the antennas. I just show it because we will go there on Saturday at the beginning of the excursion. Now, we are doing technical improvements for the BRAMS network because we got funded with a nice project called Sorbet. So you need to put a fancy name about food and you get funding. That's very nice. So the first thing is we will increase the power, and I don't go into technical details, but let's say that right now I said we transmit 130 watt, and we are going very soon to go up to 400 watts, so approximately 5 to 6 dB increase. One of the things is that it will allow us to extend internationally to France, to Netherlands, where we have planned. We discussed already with Sebastian about it. And I think for the people in UK, that might also be interesting. We are in the process of adding a second interferometer here in the Limburg part of Belgium, so not far from the Netherlands border. One of the reasons, well, there are several reasons, but one of the reasons that this part of the network is very dense. We have 12 stations in the Limburg place. So this will allow to get a lot of accurate trajectory and speed measurements using this additional data. And this is a collaboration with the University of Hasselt. Well, we already tested the place during 2 weeks. These are some kind of noise measurements that ensure that the place is extremely good for us. We have planned for next year to add a second transmitter. The idea of this second transmitter would be located somewhere there, hopefully, in the north of Belgium. The idea is that we will use the same frequency, just 1 kilohertz above, such that the signals, the meteor echoes, will appear in the same audio bandwidth as we are using now. So basically, what I mean is that we don't have to change anything to the current 46 existing receiving stations. We can use the same material, the same antenna. Of course, not all antenna will be oriented in the optimal way, but still we'll get a lot of additional meteor echoes. Therefore, that means that with the same system, we will have nearly 100 pairs of transmitter receivers. And that's all I wanted to say. Now, the scientific objectives of Sorbet, the 3 main ones are described here. The first one is determination of meteorite trajectory, speed, and orbital parameters, and then come to the operational aspects of it, and that will link to the talk of Joachim right after this. The second one is the measurements of the temperature and wind speed, so it's slightly different. Is using the meteors to really sample the MLT, the mesosphere and lower thermosphere region, so between, let's say, 80 and 100 kilometers, because that's a region that is extremely difficult to reach either by balloon, it's not possible, or by satellite either. So usually you can only sample it in situ with rockets, but that's expensive and you cannot do that everywhere, of course, and not all the time. So the meteors are doing the job very well for us. This has been done for a long time by specular meteor radars, but of course with a system like BRAMS, it was never done. So we are looking into this thing. The fact that we have so many different angles, so many different pairs of transmitter receiver, we hope that it will allow us to relax quite a lot the homogeneity assumptions. But in any case, this will be very interesting to do. And I illustrate this in this slide. So this is basically based on the Doppler effect. So the trail that was visible in the talk of Gunther at the beginning is not fixed. It's moving with the winds at this altitude that can be of a few tens to a couple of 100 meters per second. And if you calculate the Doppler shift at this frequency, you see that it's a couple up to 20-30 Hertz. So that's why all the underdense meteor echoes that you see in this image are appearing slightly above or slightly below this frequency, which is the carrier frequency, our frequency. So an important message is that we are hiring. So we are looking for a postdoc position for 2 years. So we have money from this Sorbet project that should start not near end, but actually beginning of 2024. And if you know somebody or if you are interested yourself, please contact me and I will start doing the announcement officially, I think, in 2 weeks. But if you are interested, contact me as soon as you want. So to conclude this talk, I have a quick slide about the fact that I already mentioned it, but 2 days ago we organized a meteor radio workshop with, so it was here in another room. We had 21 participants on site, which was very nice, 12 participants online. And I don't want to go into the detailed program, but I will just mention that all or most of the presentations were recorded and will soon be on YouTube. Private joke for those who are there. And the presentation will also be collected and will be soon on the BRAMS website. And I think that's it. Thank you very much.